definition for the beats is different for a general and physical definition. Okay, we can define it first of all beats. What is the right beats? Here beats when two sound waves having slight difference in frequency and traveling in a medium in the same direction, they are superimposed. They are superimposed. Then waxing and waning of sound here at regular intervals of time. This phenomena is called as beats. I will repeat again. What is the pitch? When two sound waves having slight difference in frequency and traveled in a medium in the same direction, they are superimposed. Then waxing and waning of sound heard regular intervals of time. This phenomena is called as beats. Simply, what is a beats? Simply define superposition of two sound waves having slight difference in frequency. Slight difference in frequency. The beat frequency writer formula. Here the difference in frequency is given mu1 addition mu2. Here mu1 and mu2 are the frequencies of two sound waves. Here negation is given that it is which one is higher. Let's subtract from the lower frequency. You can listen the 10 number of beats in 1 second. You may listen how many number of beats are listened? 10 beats or listen 10. Okay, what is the difference between the in general standing waves and beats? The difference between standing or called also stationary waves. The standing waves is also called as stationary waves. Here in standing waves, two waves having same frequency. Here in these two waves having slight or slight means small difference in frequency. In standing waves, two waves or two waves or travel in opposite your frequencies. And your frequencies omega 1 and omega 2. Here omega 1 is greater than omega 2 with same amplitude. Here consider observe the waves, sound wave or harmonic sound waves. Like for our convenience, assume that they start from x is equal to 0. These two waves, for convenience, our assumption x is equal to 0. They are different in frequency. So here they travel in same direction. Observe the figures. Two sound waves are traveling in a same direction and they are superimposed. The beats will be formed, getting the sound waxing and waning. Here waxing means getting maximum sound, and waning means minimum sound. Here like dum dum dum. Here the gap given intervally, getting the sound waxing and waning. Meaning means maximum sound will be produced and simultaneously minimum sound will be also produced in beats. So for our expression for the beat frequency, let us consider two harmonic sound waves. They have angular frequencies omega 1 and omega 2. Here omega 1 is greater than omega 2 and they are moving in same direction with the same amplitude in a medium. For our assumption, consider they start from x is equal to 0. The displacement of the two harmonic sound waves are given. Y1 is equal to a cos omega 1 into t. Y2 is equal to a cos omega 2 into t. According to the principle of superposition of waves. According to the principle of superposition of waves.
అయ్యో పెడితే
According to the principle of superposition of waves. What is the definition? In a medium, when two or more waves are superimposed, it means they are merged one into another. When two or more waves superimpose, the resultant displacement is equal to the algebraic sum of the individual displacement of the waves. In beats will be formed simply superposition of two waves having slightly different frequencies. So here getting the resultant displacement of the beats is equal to y1 plus y2. Here what is the y1? As the displacement of the first wave given that, and y2 is the second displacement of harmonic sound wave. Write y1 is equal to a cos omega 1 t plus in place of y2 write a cos omega 2 into t. So next step, y is equal to this goes in place. Write the term of y. Use also s. It's like a displacement. So here y is equal to in above equation. Amplitude is this common term. Take the common. So cos omega 1 t plus cos omega 2 t. Here it is in mathematics. formula. Cos C plus cos D format is equal to 2 cos of C minus D by 2 into cos C plus D by 2. This is the trigonometric mathematical formula. We know that, students. Okay, write the format is cos C plus cos D format. And next step, y is equal to, here term is there a, right, 2a cos of, you can observe t is the angle, same term, write the term cos of c, here in place of c, omega 1, right, omega 1 minus omega 2 by 2 into t. Into cos of omega 1 plus omega 2 by 2 into t. Next, omega A is equal to omega 1 plus omega 2 by 2 and omega B is equal to omega 1 minus omega 2 by 2. Terms, substitute the terms, omega A is equal to omega 1 plus omega 2 by 2 and in place of omega 1 minus omega 2 by 2 write omega B. Write this equation getting your y is equal to 2a cos omega B into t into cos omega A into t. Here this equation is given the taken as 1 a resultant displacement of the beach waves. Here 2a cos omega A t is the wave displacement. And 2a cos omega b t is given resultant amplitude. Resultant amplitude. Cos omega bt is given the resultant amplitude is variously changes with cos omega b. Here omega b is cos omega b is angular frequency. Given the beat, here intensity of beat is given getting 1 waxing and 1 van. Given the intensity of beat. Light, right, omega p is considered, what is it? Omega 1 minus omega 2 by 2. Omega 1 minus omega 2 by 2. Here 2 omega b is equal to omega 1 minus omega 2. 2 omega b is just a small difference in angular frequency, right? Delta omega equal to omega 1 minus omega 2. We know that. All of you students in previous classes made us or said omega is equal to angular frequency 2 pi mu or 2 pi f. We know that mu or f given the frequency. Write the equation in place of interchanging the value of omega with 2 pi mu. So getting delta nu equal to nu1 minus nu2. Here nu1 is greater than nu2. It is the frequency of the beat. Expression for the beat frequency. So here consider the second one is, for suppose greater value of frequency, the beat getting delta nu is equal to nu2 minus nu1. Here write nu2 is greater than nu1. It is the equation for the beat frequency. I will repeat. It is a GK question. Human, listen how many beats in 1 second?
10.
10 seconds. So 10 beats. Beats or applications of beats. Here in general, the beats are used, tuned by the musical instruments. All of you know that? The musical instruments. And also the special effects are created in cinemas. Special effects are created in cinemas. And also it is used to determine the unknown frequency of tuning fork or unknown frequency. And also the incoming receivers are used in heterodyne radios. Heterodyne radios. Right now, here beats are used to determine unknown frequency of a tuning fork. Beats are used to determine the unknown frequency of a tuning fork and determine presence of dangerous gases in mines. Dangerous gases. And next, musical instruments tuned by using beats. Special effects are created in cinema. And next, incoming receivers are used in heterodyne radios as in receivers. So I will repeat. Determine the unknown frequency or unknown frequency of a tuning fork. And second one is the determine the presence of dangerous gases in mines. And musical instruments are tuned by using beats. And also special effects are created in cinema. And next, incoming receivers are used in heterodyne radios as it is the uses of beats. And given the one example for the expression for beats of one problem. One problem for the beats. Okay, here two earthen pipes two fundamental frequencies. Of the two pipes. Here consider velocity of sound. V is equal to 330 meter per second. Here one of the examples for the beats problem. Here two horizontal pipes of length having 65 centimeters and 70 centimeters respectively. They are sounded simultaneously. How many beats are per second will be produced with the two fundamental frequencies of the two pipes? Given the velocity of sound V is equal to 320. As per solution, as per given data. Here first velocity of sound V is equal to 330 into 4 seconds. The length of organ pipes is the consider first one is L1 is equal to 65 centimeters and L2 is equal to 70 centimeters. Here observe meter per second is the SI system of unit and the centimeters for length is in inches system. So in physical problems must be converted in one system of units to solve the problems. That's why it is centimeters converting into the meters. 65 by 100, you know that 1 meter is equal to 100 centimeters. We are getting the answer 0.65 meters. And next 70 by 100 is equal to 0.7 meters. What is the main formula? So we know that the formula just only derive the equation. The beats listen for 1 second is equal to mu1 minus mu2. It is the main formula. Here pipes are given another pipe. It is not clear mentioned. It is open or closed. That's why we taken for open pipe. We get different. So here two fundamental frequencies. That's why the fundamental frequency in open pipe. Mu is equal to V by 2A. Here, write the beat frequency. Delta mu beat. Beats listen per 1 second is given V by 2L1 minus V by 2L2. The substituted terminologies L1, L2 and V. Write the substituted terms. So, beats or listen for 1 second is given. The value of V is 330 by 2 into L1 value is 0.65 minus 330 by 2 into 0.7. So it is multiplied with the 2 in division. 330 by 1.3 minus 330 by 1.4. And next, here simplifying the answer, 330 by 1.3 getting the answer 253.8 and also 330 by 1.4 getting the answer 235.7. This is separate from higher to lower line getting 18.1 or 18 edges. Here the beat frequency listen resonance is the natural vibrational frequency of the body is equal to the external periodic force acting on it. Then said the body is in resonance. In resonance, the amplitude will be increases or it vibrating with the maximum amplitude. Here I will write the formula for resonance. If the natural vibrational frequency of a body is equal to the external periodic force acting on it, the body is said to be in resonance. Here, when body is in resonance, its amplitude increase or maximum. So it will be vibrate with the maximum. To determine the velocity of sound in air, to determine the velocity of sound in air. So it is especially using by the resonate operator. A resonate operator consisting a glass tube and scale, also a water reservoir. The water reservoir and glass tube connected with the parallel. It is like a glass tube. In our practical purpose, it may be used also iron tube, but it is connected with a pipe, white color pipe. So here, the water level in a glass tube is moves up or down with the help of adjusting the water reservoir. It consists in a scale to measure the water level in the glass tube. So it is called a resonate operator. It is called a resonate operator. It working on the principle of resonance. The resonate operator will be working on the principle of resonance. Here, just take a known frequency of tuning fork will be vibrated and held on horizontal top of glass tube. Top of glass tube. Here the water level moves down in a glass tube, slowly adjusting with the help of moving down the reservoir. At which point booming sound or which will be vibrate with the maximum sound heard are called booming sound. The booming sound is here at which point now down the resonating length. Here it is a closed pipe because it is one end is open, another end is closed. So just like in first resonating in glass tube form like this. It is the full of water here form. The first resonating length is given and 1. First resonating length is measured with the help of scale. You are getting here one anti-node and node. That is, we know that the distance between the corresponding nodes and anti-node is given lambda by 4. And consider the resonator operator correction is 0 for our convenience. And next step, second resonating length will be measured. Also similarly, at which point getting the booming sound for the same frequency of tuning fork. So note down second resonating length. Here L2 is equal to, at which point like getting here falls. So, with the help of adjusting the move down the water reservoir, not down the booming sound. So here, getting the second resonating length is third times of first resonating length, or third multiple of the first resonating length. Here, the difference between the two resonating lengths, difference between two resonating lengths is given L2 minus L1 equal to, what is L1? Lambda by 4. And what is L2? Here, what is right? L2 minus L1. 3 into lambda by 4 minus lambda by 4. Here, getting the simplifying, L2 minus L1 is equal to, L2 minus L1 is equal to, getting 2 lambda by 4. 2 1 ja, 2 2 ja. And next step, getting the answer. So here, simplifying the answer, getting here lambda by 2 getting is equal to L2 minus L1. And lambda is equal to 2 into L2 minus L1. We know that V is equal to mu lambda, velocity of sound. Here mu is the frequency of non-tuning fork and lambda is the wavelength. Here in this equation, lambda is equal to, write V by mu. In our equation, in place of lambda, write V by mu. So V by mu is equal to 2 into L2 minus L1. And next, V is equal to 2 into mu L2 minus L1. It is the further determine the velocity of sound by using the resonating method. So it is the practical purpose is used to find out the velocity of sound by using the resonating method. L1 is the first resonating length, L2 is the second resonating length, and mu is the frequency of non-tuning fork, and we know that V is the velocity of sound.
Okay.
It is the example for the forced vibration. It is also in the topic is seen in like a oscillation. On example for the resonance, it is only for the problem is not important, but it is the practically important in practical examination for salvation. Taking the one problem for example on resonance. Here a vertical tube is made to stand in water so that the water level in the top the tube. If standing waves are produced at two successive water levels of 20 centimeters and 73 centimeters. What is speed of the sound wave in what is the speed of sound wave in the tube or air tube? So here first a vertical tube is made of stand in a water so that the water level will be adjusted. Sound waves are frequency, it will be vibrate. External periodic frequency is 320 or sent in the tube, top of the tube. And if the standing waves are produced two successive water levels at 20 and 73 centimeters. So you will find out what is the speed of sound wave in the tube. So here as per given data, first the frequency of tuning fork. Frequency of tuning fork. No frequency. Mu is equal to 320 Hz. And next given first resonating length of 8 coil. L1 is equal to given 20 centimeters. And second, a resonating length of 8 coil 1. L2 is equal to 73 centimeters. Here, Hs is the SI system of unit. The physical quantity is length. Converting into the SI system, right getting 20 by 100 meters is equal to 0.2 meters and 73 by 100 is equal to 0.73 meters. The main formula for resonating. So, resonating formula. So, velocity of sound V is equal to 2 mu L2 minus L1. Just before 10 minutes back, we can derive the equation for resonating. So, velocity of sound. Here, substitute the all terms getting the velocity of sound. Here, V is equal to 2 into frequency is that 320 into L2 value is 0.73 minus 0.2. Here 2 into 320, getting the answer 720 into. Here 320 into 2, getting 640 into 0.2 is subtract from 0.73, getting 0.53. Here it is simplifying the answer. Getting the velocity of sound 339.2 meter per second. So it is the answer for the solution for the given problem. I will repeat the problem. So first, what is the given data? It is given the data frequency of tuning fork is 320 Hz and first resonating length, it is booming sound at 20 centimeters and second resonating length getting 73 centimeters. Here the main formula, velocity of or speed of this sound wave, getting the formula V is equal to 2 into mu into L2 minus L1. Here mu is the known frequency of tuning fork 320. Substitute the terms L1, L2 and mu. So write 320 into 2 equal to 640 and 0.2 is subtract from 0.73 is getting 0.53. It is simplifying or multiplying with the answer getting 339.2 meter per second.